Your AWS account has a credit card attached. A breach can spin up thousands of servers instantly, leading to bills that could bankrupt a small business. Multi-factor authentication, or MFA, is a quick setup that makes this virtually impossible. This program is Module 3, Episode 2 of the Understanding AWS and Cloud Services course, brought to you by the Series of Thoughts team. AWS accounts are high-value targets, and a single compromised login can have immediate, measurable financial consequences. By the end of this video, you will have MFA enabled on your root and admin accounts, understand access key risks, and know how to prevent common attacks. Chapter 1 covers how AWS account takeovers actually happen. Understanding these real attack vectors, in plain English, is the first step to defending against them. These exploits occur daily to developers and small businesses. The three most common attack vectors are credential stuffing, phishing, and exposed access keys. Credential stuffing uses leaked passwords. Phishing uses fake login pages and emails. Exposed access keys occur when developers accidentally commit keys to public GitHub repositories. The most common outcome of an AWS breach is crypto mining. Attackers use high-powered EC2 instances to mine cryptocurrency, leaving developers with huge bills. While AWS may waive charges once, the risk and stress are devastating. This is not a theoretical risk. Automated bots scan GitHub continuously, exploiting leaked access keys in under 4 minutes. Security researchers have confirmed these scanners target any credential hitting a public repository. One accidental Git push is all it takes. In Chapter 2, we explain MFA simply. Multi-factor authentication combines two independent layers of proof. Even with your password, an attacker cannot gain access without your second factor, which is on a device only you possess. MFA combines something you know, your password, with something you have, a time-based one-time code from your phone. This creates exponential protection. Compromising two independent factors simultaneously is practically impossible for common attacks. MFA completely neutralizes password-based attacks like credential stuffing and phishing. While not a silver bullet for every threat, it addresses the two most common attack vectors. A different set of best practices applies to access keys, covered in Chapter 4. Chapter 3 focuses on setting up MFA, starting with your root account. The root account is the master key to your AWS environment, capable of bypassing IAM policies, closing the account, and accessing billing. Protect it first, and use it rarely. To enable MFA, sign in to the AWS console with your root account. Navigate to Security Credentials and scroll to the Multi-Factor Authentication section. Assign an MFA device, choosing an authenticator app. Scan the QR code, enter 2 consecutive 6-digit codes, and confirm. Log out and back in to verify. When choosing an authenticator app, both Google Authenticator and Authy are free and widely used. Google Authenticator is simpler but lacks cloud backup. Authy supports encrypted cloud backup and multi-device sync. For AWS, remember to store your MFA backup codes in a password manager. It's critical to also secure your IAM admin user, the account you use for day-to-day work. The setup process is identical to the root account. Once both accounts have MFA enabled, credential stuffing and phishing are neutralized. You've completed the highest impact security action available to any AWS user. Chapter 4. Access keys are more powerful and dangerous than passwords. They grant programmatic access to your AWS account, entirely bypassing console login. Understanding when to use them and how to handle them safely is essential security knowledge. An access key is a pair of credentials, an access key ID, and a secret access key. Together, they allow any program to make API calls on your behalf without a browser or MFA. You need them for running CLI commands, applications, CI/CD pipelines, and local development scripts. If only using the AWS console, you may not need them. Access keys pose greater dangers than passwords. They lack MFA protection, grant immediate access, and are easy to expose. They can be hard to track and are often overpowered by default, violating the principle of least privilege. The GitHub exposure problem is one of the most immediate dangers. Accidentally committing access keys to a public Git repository allows exploitation within minutes, not hours. This quick window is why key management is so critical. This sequence is painfully common. A hard-coded key is pushed to a repository, detected by a bot, and immediately used for a crypto mining attack. Using a .gitignore file and environment variables are primary defenses against accidental commits. AWS Secret Scanning is an automated safety net in partnership with GitHub. If an access key is exposed publicly, GitHub alerts AWS immediately. You receive an email alert and guidance, but remember, this is a reactive measure, not a strategy. If a key is exposed, act immediately. Deactivate the key now in IAM. Review CloudTrail logs for unusual activity. Delete the key entirely after confirming damage. Finally, contact AWS support if you see unexpected charges. Chapter 6 covers access key best practices. While keys are necessary, careful management dramatically reduces exposure without adding friction to your development workflow. We will explore key rotation, least privilege, and safer usage methods. Rotate keys regularly, ideally every 90 days. Implement least privilege permissions by creating dedicated IAM users instead of using admin keys. Audit unused keys and deactivate those not used in 90 days. Always use environment variables, never hardcode keys in file. For applications running on AWS infrastructure like EC2 or Lambda, IAM roles are a better alternative to hard-coded keys. Roles provide temporary, rotating credentials automatically through the instance metadata service, eliminating the need to store static keys. AWS Cloud Shell is a safer console alternative for CLI tasks. It's a browser-based terminal built into the AWS console, authenticated automatically using your console session. This removes the need for local access keys for administrative work. Cloud Shell is protected by your console's MFA and requires no local keys. It comes with the AWS CLI, pre-installed and configured, offering a seamless experience. It also provides 1 GB of persistent storage per region for your scripts. In the live demo, we will cover the full access key lifecycle in under 5 minutes. This includes enabling MFA, generating a key, deactivating it immediately in response to a simulated exposure, and then deleting it permanently. This demonstrates how to manage keys safely. This spectrum shows the danger level of different access methods. Aim for the top 2 levels, using roles or MFA-protected console access. The most important fix is eliminating local admin-level access keys from your workflow. Your security checklist should include root account MFA, IAM admin user MFA, an access key audit to remove unused keys, and verification that no keys are hard-coded in your codebase or committed to version control. MFA makes the most common attack vectors completely ineffective. Before MFA, an attacker with your password has full access. After MFA, even with your password, an attacker has nothing they can use to access your account. The key numbers are striking. 4 minutes is the average time to exploit a leaked key. MFA prevents 99% of password-based attacks. It takes 2 minutes to set up and costs $0. There is no reason not to enable this vital protection. Let's review common mistakes to avoid. Firstly, never use the root account for everyday work. Lock it away after initial setup and use an IAM admin user for daily tasks. Only log in as root for essential account closure or billing needs. Secondly, avoid creating access keys just in case. Only generate them for an immediate, specific need. Unused keys are security liabilities and should be deleted if not used within a week. Finally, never share access keys with teammates. Every user needing AWS access must have their own IAM user and credentials. Shared keys mean zero accountability and no clean path for revocation when someone leaves your organization. This table is a quick reference for credential types. Console passwords with MFA are low risk for human logins. IAM roles are the preferred approach for applications, as they use temporary credentials and are very low risk. Access keys, used for programmatic access, are medium to high risk if mishandled, as they are not MFA protected by default. Cloud Shell sessions are very low risk, inheriting your console's MFA for ad hoc CLI tasks.